So today we're talking about writing repeating decimals as fractions. So we're going to do this algebraically by following our steps over here. So the first thing is to skip a little space, and then you're going to set 1x equal to whatever your decimal is. Now I'm actually going to write out my decimal a couple places just so you can see this for the next step. But you can always use bar notation as well. Now, what you're going to do is based off the farthest place value. So in this one, it goes to the tenths before it starts repeating. So the farthest place value, you're going to multiply both sides of your equation here by your place value. So in this case, I'm going to multiply by 10 on the left side and multiply by 10 on the right side. Now, when you multiply this repeating decimal by 10, it basically is just going to make it where one repetition of the 4 is in front of the decimal. Right? Then what you're going to do is you're going to end up subtracting these two equations. So 10x minus 1x is 9x. And then what happens is these repeating decimals, because they're identical, they're actually going to end up canceling each other out. So these are going to cancel out. I'm going to be left with 4 minus 0, which is 4. And then I'm just going to divide to get x by itself. So I'll get this fraction that x equals 4 over 9. So this is actually my repeating decimal as a fraction. And I could check it by actually taking 4 and dividing it by 9. Well, it can't go in, so I got to add a decimal and a 0. But 9 can go into 40 4 times. That would be 36. So when I subtract, I'm going to get 4 again. I still add a 0. I'm going to keep getting that 4 over and over and over. So I could check to see that I do, in fact, get 0.4 repeating. So it's the same idea on this next one. So again, first step is to put 1x equal to my decimal. I'm going to write this one with the bar notation, just so you can see it that way as well. Since the farthest place value here before it starts repeating is the hundredths, then I'm going to multiply both sides by 100. So that'll be 100x equals 24.24 repeating. And again, when you're multiplying by that place value, all it's going to do is take one repetition of the repeating part and put it in front of the decimal. Again, I'm going to subtract. 100x minus 1x is 99x. These decimal places are going to cancel each other out. I'm going to have 24 minus 0, which is 24. And then I'm going to divide to get x by itself to get 24 over 99. Now the thing is, this actually can simplify. Both of these are divisible by 3. So I will simplify to get my final answer, which is 8 over 33. So do double check to make sure that you can, if you can simplify. And again, I could actually take my calculator and divide 8 divided by 33 to see that I do actually get 0.24 repeating. Or I can do it by hand. Right? So this one actually has two ways that you can do it, so it's kind of up to you which way you want to do it. So you could either do it where you are going to get a mixed number, or you could do it where you're going to end up getting an improper fraction. So remember, improper fractions mean that the larger number is on top. Okay? I think the mixed number is a little bit easier, but it's kind of personal preference. So if I'm doing a mixed number, since there is a whole number here, so since there's a number in front of the decimal, that means that my answer is going to have a number in front of the fraction. In this case, it's 2. So then what I'm going to do is I'm going to look at it just as though it was 0.17 repeating. I'm going to take that 2 off because I've already included it in my answer. And then I'm going to set it up just like we did before. Set 1x equal to your decimal. Since the 7 here is in the hundredths, I'm going to multiply everything by 100 and subtract. And again, your repeating decimals here will cancel each other out. When you divide, you're going to bring this fraction down after your whole number. So this would be 2 and 17 over 99. I would check to see if this can simplify, but it cannot. So I'm going to leave it as 2 and 17 over 99. So if it asks for a mixed number, this is the method I would definitely use. please, please, please be careful not to forget this too. If you notice, the very first thing I did when writing my answer was I went ahead and brought that down so I would be less likely to forget it. So that's kind of the nice thing about the improper fraction version is if you're really bad about bringing those values down, you probably should do it as an improper fraction. So if you're doing the improper fraction, you're going to leave the 2 in the front. So you're going to leave the 2 in front. So same process though. Set 1x equal to your decimal, which includes that 2 in front. This is still in the hundredths. So I'm going to multiply by 100. Now when you multiply by 100 on this one, it's still going to have the 2 in front, and you're going to bring one repetition of the 17 in front of the decimal, so it's going to look like this. When you subtract, you're going to get 99x. And then here, remember your decimals will cancel out. But now I have 217 minus 2, which is 215. And then I can divide. And I'll get x is equal to 215 over 99. Now, if I wanted to make this a mixed number from here, I could figure out how many times I could divide 215 by 99. Well, when I do that, it can go in twice. And then I would still have 17 left over. So either one of these is an acceptable answer unless they specifically ask for it as a mixed number or as an improper fraction. So make sure you look to see how they ask for it. For me, because all I said was a simplified fraction, I would take either. So both of these are true, and they're both already simplified as much as possible. All right, so then I want you to try these two on your own. So pause it and then unpause it to check your work. So on this one, we've got 1x equals 0.6 repeating. Well, this is in the tenths place, so I'm going to multiply by 10 and subtract. I'm going to get 9x equals 6. And then I'm going to divide both sides by 9 to get that x is 6 over 9, which can simplify to 2/3. And don't forget, you can always check your answer by actually dividing this, and you should get 0.6 repeating. And then number 2, I'm going to bring down my 3 in front, because I prefer to do the mixed number version. So I'm looking at the decimal 0.23 repeating for the rest of this. So I have 1x equals 0.23 repeating. The 3 is in the hundredths place, so I'm going to multiply by 100. Then I'm going to subtract. I'll get 99x equals 23. So that when I divide, I'm going to get 3 and 23 over 99, which is already simplified. If you decide to do this as an improper fraction, it's going to look very similar. You would have 1x equals 3.23 repeating, so that when you multiply by 100, it's going to look like 323.23 repeating. So you'll get 99x equals 320. So you would have gotten that x is 320 over 99. So that's the other way you could have done this. And it is, again, still simplified. So either one would be acceptable. So the last thing I wanted to look at is the pattern that we see here. So if we look at the unsimplified versions, what happens, okay, is like on these where there's only one value repeating, you've got the number that was repeating on the top, and then you've got the place value minus 1 on the bottom. So for example, on this one, you're going to have the decimal on the top. So that happens to be 3. And then you're going to have the place value minus 1. So the 3 is in the tenths place. Well, 10 minus 1 will be 9. And then this can simplify to give you 1/3. So if I actually divide 1/3, I do get 0.3 repeating. Same idea on these. So I'm going to bring over the whole number, My 7 is what's repeating. It's in the tenths place, so 10 minus 1. So that'll be 5, negative 5, and 7 over 9. Now on these, you've got the hundredths place is what's repeating, so same idea though. So I'm going to take my decimal over the place value, in this case it's in the hundredths, minus 1. So that'll give me 13 over 99. And then I'd simplify if I could. Same idea here, so if you have a whole number, 4, and the 24 is what's repeating, over the place value, which is 100, minus 1. Now this one actually simplifies, both of these are divisible by 3, so then I get 4 and 8 over 33. Now this one, we didn't talk about one like this, but it's the same idea. So I'm going to bring the 8 over. 127 is what's repeating. This place value is the thousandths. So this will be 1,000 minus 1. So this would be 127 over 999. And although it doesn't look like it, it actually is simplified as much as possible. Now, the thing is, this pattern is all wonderful, okay? But on your test, to get full credit, you would have to show me your work like you did on these problems right here. Without showing your work, if you just remember the pattern, you will only get half credit. Now, it's still nice in case you forget the steps, or that if you want to check your work, okay? That's why we talk about the pattern. But again, to get full credit, you would have to show me these steps.